we can do the same thing as first hour. We got a lot of homework done in class. It felt good. So it says, show me, you guys just tell me, what were the possible rational roots? Thank you. And then when you guys were testing, which one actually worked? So you did -1 and you got a new set of numbers down here. What were they?
1, -6, 6 times 0.
Perfect. So you knew the remainder was 0. That's how you knew it was a 0. So -1 was a rational root. But then also, this is how you should continue tackling it. And I saw most of you do this. You look at the quadratic. We took a degree 3, we divided by something linear, and we got degree 2. So then you looked at this and you saw if it factored. So you said, what multiplies to be 10 and adds up to be -6? Nothing, so it doesn't factor. So to solve this, it would take the quadratic formula. I asked you for rational roots. Quadratic formula gives me imaginary and irrational, so I'm done. Right, everyone? Now, what's cool is we really don't have to learn anything new today. The only thing different is we would keep solving. I want you to find the roots, period. Does that make sense? Yeah. So really, that's it. So that's kind of cool. Okay, so that's called the fundamental theorem of algebra. You don't need to write it down because you already know it. I'm going to say the fundamental theorem of algebra out loud, okay? The fundamental theorem of algebra says that the highest degree of a polynomial is the number of solutions, which we already know, right? The highest degree is the number of solutions we have. And what we're going to do today is find all solutions. Okay, so let's read this. It says, you can factor any polynomial of degree n into n linear factors. But sometimes factors will involve imaginary numbers. Now technically, for us to get these, we'd be doing the quadratic formula. But then we could work backwards to get our linear factors. It says the degree of a polynomial equation tells you how many solutions the equation will have. It is easy to see graphically that every polynomial function of degree 1, so look over there at the line, will have a single 0, the x-intercept. However, there appears to be 3 possibilities for a quadratic. So look right here. It corresponds to these graphs. So look at this graph. It crosses the x-axis in 2 places, so we have 2 real zeros. Now right here, it has 2 solutions. It's just it's touching down and bouncing back up, so this would be x equals 1 with a multiplicity of 2. So that's still 2 solutions. And then right here we have 2 solutions, but they never cross the real number line, so they would be imaginary. And we know imaginaries come in pairs, so it makes sense. Is that everyone good? Okay, degree 2 will have 2 solutions of some type. Okay, so now it's going to say the word complex roots. Complex numbers are actually any number. So let me explain that. A complex number has the form a plus bi. Well, technically all numbers have that form. So look at these examples. Right here, this is pretty obvious. A plus bi, that's a complex number. Now right here, it actually is a complex number because it's technically 4 plus 0i. So 4 is a complex number too, technically. And then this, look, a plus bi, that's all good. And then technically, even 6i is a complex number because that's 0 plus 6i. So if I say to you, find all the complex roots, aren't I saying find any root? Imaginary, whole number, imaginary, and imaginary. You guys see what I'm saying? Anything can be a complex number technically. So finding complex roots just means find all solutions, period. Yes?
Would a square root be one of those two?
Yeah, great question. So like if we had root 3, that's a plus 0i. So that would be considered a complex number. Good question, because I didn't have any examples like that. All right, so, oh dear me, why is that so small? Oh no, can you guys see that?
Yes. Yes, I can.
I'll write bigger though. Okay, so it says, without the use of a calculator, find all the complex roots of the equation. That just means solve, period. So what we're doing today is using our knowledge of the fundamental theorem of algebra that there are 5 solutions, and we've got to go through and somehow find all 5 solutions. So this is our thought process, guys. We always want to solve using the easiest way for us. That's why we learn so many methods, so that we can do the easiest thing possible. So while you look at number 1, notice, we do not know any way to factor that. So the only way to solve this one is to try P over Q. That's our least favorite, but that's the only way we know how right now. Everybody good? So let's list out the possible rational roots. So factors of P. So remember, P is always the constant, and then factors of Q. So factors of P, plus or minus 1, plus or minus 5. Factors of Q, plus or minus 1. So our possible rational roots, P over Q, would be plus or minus 1 over 1 and plus or minus 5 over 1. So guys, if we have a fractional solution, it's going to be one of those. Okay, let's start testing. So now we could use the idea of the, what's it called? Sorry, I keep doing this. The theorem we learned yesterday. This is the rational root theorem, but the other one. Descartes' rule of signs. I keep calling him Demore. I don't know who Demore is, but they're in my mind today. Descartes' rule of signs allows us to know how many positive and negative real roots we have. We could use that to see which one we test first, but honestly, there's not that many. So I'm just going to go for it. So 1, start testing that. So 1, negative 3, negative 8, negative 8, negative 9, negative 5. Somebody test negative 1. Let's split it up so we can go quicker. But I only want those two being tested for right now. I'll tell you why in a second. So test those two. So you guys probably can go a lot quicker than I can through this. Yeah, 1 and negative 1, I only want those being tested right now. One didn't work.
Yeah, no, it did.
Negative 1 works. Awesome. So now I'm going to have us write down the new numbers you got down here. So we won't go through it because we know how, but tell me what numbers you got.
1, negative 4,
5 and 0. Okay, so because we got the 0, we knew that negative 1 was a solution. So make a special box where you put your final answer. So x equals negative 1 is definitely one of our solutions out of the 5. So now what you're going to want to do is, from here, write down the new polynomial and see if we can solve the rest by a different method that we already know, like factoring. So let's write down. Now everyone, we went from degree 5, back at the top, we divided by something linear, so now we have a degree 4. So 1x to the 4th minus 4x cubed minus 4x squared minus 4x plus 5. So now you'd say, yes.
The 5 is a minus 5. Yeah. Because you have to have negative 5 times negative 1 plus positive 5, which is, so it would be minus 5.
Oh, right, here's minus 5.
Yeah.
Okay, awesome. Okay, we'll hurry and fix that. Thank you. So then right here, so now we look at this new polynomial. Still, we have too many terms to do grouping, right?
Yeah.
We still don't know how to solve this. So now here's the thing though. We're going to keep testing, but we're not going to go back to the original polynomial. We could, but then we're going to be in the same boat. We're not going to be able to continue solving. We're going to get to something like this and say, well, I don't know how to factor that. So what you can do is, guys, this polynomial will have the same solutions as the original. It will. It will cross through the same places. So why not take this degree 4, this smaller polynomial, and use it to test the other values? Because if one of them works, then we'll be down to degree 3, which you see how we're getting better to solve. The smaller, the better. So let's keep testing. So use these coefficients. 1, negative 4, negative 4, negative 4, negative 5. And let's test 5 and negative 5, because those are our only other two options. So let's test negative 5 and 5. Sorry. Somebody split it up and start doing 5 as well. 5 works? Okay, then I won't keep going with negative 5 because I don't believe it works.
Yeah, it doesn't.
Okay, so what did you get when you divided by 5? Like that? One more 1. That's not lined up very good, but it's okay. You get the picture. So we got a 1, a 1, a 1, a 1, a 0. So we knew because that is 0 that 5 was the solution. So sorry, I'm going to make the new box down here. So we had x equals negative 1, didn't we? And now we just got x equals negative 5. Okay, we have 2 of the 5 solutions. Oh, for each. 2, okay, x equals positive 5. Okay, here we go. So now we would look and say we took degree 4, and we divided it with something linear, so we get degree 3. So we have 1x cubed plus 1x squared plus 1x plus 1. Well, now we have a polynomial that we can solve by factoring by grouping. So now we've gotten it small enough that we do know how to solve it. So here we go. Let's try grouping. If it works, it works. If not, we'll have to figure out something else. So we'll pull out x squared. So we know we divide by x squared, giving me x plus 1. Pull out a positive 1. We always have to pull out something. We can pull out a 1. So then we would get x plus 1. We know it does factor by grouping since these are the same. So we factor out x plus 1, and left is x squared plus 1. So now we'll solve each of those. So we get x equals negative 1. Didn't we already have that?
Multiplicity of 2.
Well, good. Multiplicity of 2. So write that down because you have to count to make sure you have enough solution. And then we'll solve here. So x squared plus 1. Don't do it in your head because a lot of you will mess up and just square root it right here. So do the algebra. So we have x squared equals negative 1. Now square root it. So x is equal to plus or minus I. So we got x equals I and x equals negative I. Let's count how many solutions we have. 1, 2, 3, 4, 5. It was degree 5, so we're not missing anything.
Yep.
And we're done. Yay. Okay, number 2. Now I do want you to use, why do we learn all these methods? To use the most appropriate, easiest way to solve. So look at number 2. Don't we only have 4 terms? Wouldn't it be wise to try factoring by grouping? We could do P over Q, but P over Q is our last choice. That would be a silly thing to do. So now we'll pull out x squared. Left is x minus 2. Pull out a positive 4. We know we're good because inside our parentheses is the same. So now we'll set each of those equal to 0. So x equals 2. So x is equal to plus or minus 2i. Then count, find a final place for your final answers. 1, 2, 3 solutions. It was degree 3, so we're good. Okay, looking at this one. Now look, there is 4 terms, so if we did try factoring by grouping, let's see if it would work. So just watch because it doesn't turn out working. We'd pull out x squared, left would be x plus 1. We'd pull out negative 1, left is x minus 2. Not the same. So you'd say, no, I can't factor by grouping. So we gotta do P over Q because that's the only other way we know how to do it. So factors of P. Factors of Q. So plus or minus 1, plus or minus 2. Q is plus or minus 1, so P over Q would just be 1 and 2. Okay, there's not that many, so I'm just going to probably just start testing. But honestly, I can see how many positive? 1, so I guess I'll test the positives first. Nope to 1. Nope to 2, right? Okay, well, let's move on to our negatives then. I just got no to negative 1. Our last hope is negative 2. But remember that it doesn't necessarily have to be rational.
Oh, right.
Yeah. There it is. Awesome. So we have negative 2. So find a final place, a final box with your final answers. We get x equals negative 2 is a solution. Now check. We took degree 3. We divided it by something linear, so now we have degree 2. So x squared minus x plus 1 equals 0. If it factors, we'll solve by factoring. Well, multiplies to be 1 and adds up to be negative 1. Nothing. So we have to use the quadratic formula because in this lesson it says find the solutions, period. So here we go. X equals negative b plus or minus the square root of b squared minus 4 times a times c. Then guys watch. People are doing this. Oh, this over 2a. No, it's all over 2a. So we have x is equal to 1 plus or minus. Remember, you type that into your calculator. It comes out to be -3 all over 2. So our final answer here is x is equal to 1 plus or minus I root 3 all over 2. And you'd say I have 3 solutions. It was degree 3, so I've solved them all. Let's say that you graphed it. This would cross the x-axis at -2, and it would not cross again because our other two were imaginary. So it makes sense.
Would it be like
this, something like this. All right, so what I want you to do is 1 through 6. So it says, find all the zeros. That means find all the complex roots or find the solutions. We're going to use the easiest way possible. So we first look for a factoring method we've learned this year. So let's look at this one. How would you, we'd set it equal to 0, and then what would you do? How would you solve this one? Take out a 5x. We always look for greatest common factors first with polynomials. So then left in our parentheses would be x squared minus 1. Now set each of those equal to 0. 5x equals 0. X squared minus 1 equals 0. Now everyone always gets thrown off with this. Not everyone. A lot of people get thrown off with this. They're like, what the? But guys, 0 is divided by 5 is just 0. 0 is just as good as any other number. 0 is no worse than a 1 as a solution. We understand that? Okay. 0 is just on the real number line too. So now we'll add 1. X squared equals 1. So x is equal to root 1, which is 1. So we'd say x equals plus or minus 1. So then count degree 3. We have 3 solutions. We're all good here.
Yep.
Continuing, number 9. So let's look for the most appropriate method to solve this one. Don't start doing quadratic stuff. It's not quadratic. Divide by 2 and? So what you really meant was, yeah, you're right. Pull out to 2x, and now we'll divide by 2x. We have a 6x squared minus x minus, you know what someone did first hour and it broke my little heart? They said, oh, it's gone, and then they closed it here.
Wrong.
Minus 1. Okay, good. Don't forget. It was good because then they remembered from now on they'll never forget. So we have 2x equals 0. And we have 6x squared minus x minus 1 equals 0. I'm going to see if it factors. What multiplies to be -6 and adds up to be -1, 3 and 2, right? -3. So now I'm going to, really quick, we got a long factor. So 9x squared, drop and break, you know, minus 3x plus 2x minus 1. Factor by grouping. We know how to long factor, hopefully by this point in the year. Is it positive 6? Nope. A times c is negative. But good point, because if it was a positive 6, we couldn't do it. And I've made that error many a times where I kept doing it even though it only worked on one side. So good point to make sure. So we pull out a 3x, 2x minus 1, we pull out a 1. So we're almost there. Okay, awesome. Let's write out in our box our final solutions here. So divide by 2, divide by 2. So our first solution was x equals 0. Then right here we would set it equal to 0 and solve. So let's see what we get. X equals?
No, 1. 1/2.
Positive 1/2. Set it equal to 0. Add 1. Divide by 2. All right. Then the next one. Negative 1/3. Degree 3. We have 3 solutions. So we haven't even had to use P over Q yet. And number 12. And then I'm going to let you go for it. How would you solve this one? Good thought, but if we cube root, we're in some trouble just because there's not cube roots. Okay. Good. Pull out -4x. Why did you say negative?
Because it was leading closest to negative.
Yep, awesome. We should always factor out a negative. Way to remember that. Pull out a -4x. So then you have x squared.
Minus 25.
Good, minus 25. So we have -4x equals 0.
Sorry.
Okay, all right. solutions. Okay, awesome. Now go ahead and finish up the 1 through 12. So 7 through 12 is the next section. Keep going with those. Instructions, it says, for each equation, state the number of complex roots, the possible number of real roots, that means crosses the x-axis, and what are the possible rational roots. So the number of complex roots, that just means complex, remember, is any type of root. How many roots does it have? 2, okay? Then the number of real roots, it could have possibly. Now real means crosses the x-axis, so it could have 2, but it also could have 2 or 0. Does everybody understand why? Now think about it. It's going to have 2 real or 2. It could have 2 imaginary. It has to be 2 imaginary. There's no such thing as having 1 since they come in conjugate pairs. So really, how it works is it goes with the highest degree and then down in 2s. So the number of real. And then it wants our p over q's. So factors of p, plus or minus 1, plus or minus 3. Our q's, plus or minus 1, plus or minus 2. So p over q. Because it doesn't say how many possible rational roots it wants them. So 1, 1/2, 3, 3/2. That's it. Now let's answer this one so easy. Okay, let's read the instructions. Oh wait, do you want to do one more like that, or do you? Oh yeah, we do need to do one more like that. Okay, just because people sometimes have a hard time. Okay, what's the number of complex roots? 5. Okay, how many real roots could we have? Possibly. We could have 5. It could cross 5 times. 3 or 1. True. Now think about why that is. If we have 5, then we have no imaginary. That can happen. If we have 3 real, then we would have to have 2 imaginary, which would be 5. That's good. If we have 1 real, we would have to have 4 imaginary because you'd have to have 2 pairs of 2. Awesome. And then p over q. This one will have quite a few more. Factors of p, plus or minus 1, 2, 3, 6. Factors of q, 1, 2, 4. I know, huh? I sometimes cannot write and think at the same time. Okay. Yeah. Because in the instructions it doesn't say to do anything else. Now let's read number 25. Find the number of complex roots. What's the answer? 8, and we're done. If it didn't ask anything else, read the instructions and then you're done, you've answered it. Okay, so in that section do 13 through 24, do odds only, because if you understand those, you understand all of them. But then do 26 through 30, do all. Number 32, it says, find all the zeros. So we've set it equal to 0, use the most appropriate method. There's 4 terms. I'm going to try grouping, and then if it doesn't work, we'll go from there. So right here, we would pull out a 2x squared. So then we would have x minus 4 left. Right here, I'm going to pull out, looks like positive 18. Then left is x minus 4. And look at that. It did factor by grouping. So x equals 4, and then I'm going to do the math here. So I have 2x squared equals negative 18. X squared equals negative 9. So x is equal to plus and minus 3i. 3, degree 3, should have 3 solutions, so we are all set. Number 36. If we try factoring by grouping, it doesn't work. So we're going to have to do p over q. Okay, now anything, then my q's are 1, so I'm good right here. Everything divided by 1. Now we could use the card's rule of signs to see which ones we should maybe test first. So positive to negative, negative to negative, so there's 1, and then negative to positive, so it's either 2 or 0 positive, so I'm not going to necessarily do that one. And there's, yeah, one negative. So try -4, okay. Yep. Nope. Nope, -4 is not going to end up working out. -2 doesn't work either? Oh. Perfect. Yay, we found it. No, we didn't. Nope. So we know it's not -2 or -4. Did we try -1? Anyone? That one doesn't work either. It's -3? Okay, awesome. Perfect. Okay, we just found it. So our final box here, we have an x equals -3. Then we took a degree of 3. We divided it once, so we now have a quadratic. X squared minus 5x plus 4 equals 0. Let's see if it factors. That really will be the easiest. What multiplies to be 4 adds up to be -5. 1 times 4, negative. Quick factors, luckily, x minus 1, x minus 4. So our other two solutions are x equals 4 and 1. Good. Degree 3 has 3 solutions, so we're done. Hey, if you guys are getting the picture here, we're good. Now look, people will treat this like a quadratic. They'll try to factor it. It is not quadratic. It doesn't work. So we have to do P over Q in this one. Do you want to do it together, or are you guys good? Okay. Now look, how would you do 41? Awesome. U substitution. This would be a U substitution because it's quadratic in form, everybody. You say let U equal x squared. You're going to see this stuff again on this upcoming test. And you go through and factor it. And then continue. Do you want me to continue? Are you guys good? We just tested on this. Okay, I don't want to waste your time. Okay, that's the end. Finish the worksheet.